To review lesson 1 with the trig ratios, we went over the 3 ratios of sine, cosine, and tan. So sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. So as established last week, the most important part is labeling it correctly and identifying where are the lengths that I need and or where are the angles that I need. So if we take the four rectangles at the top, all right angle triangles, so that is what is required, that we have a right angle in the triangle and that we be given, or we know at least 2 of the dimensions, so either 2 sides or a side and an angle. So if this first triangle, if the identified angle is here, so that's where we know, we have to first label it. Opposite of the right angle is your hypotenuse, and the furthest side away is your opposite. And I always think of it again as the angle that's attached, or the side that's attached to the angle, or the side that's closest to the angle is your adjacent. So practicing labeling those are the most important. And here I'll show an example of what happens if the problem requires us to find more than one piece, or they give us different angles for different reasons. So if you saw that in brown or gray, but then if we had this angle here, this would no longer be the opposite. Now that this side length on the top here is attached to this angle, this is now the adjacent. This is going across to the opposite, and this is still our hypotenuse. So again, it's all relative to what angle is given. So if I said here, this would be adjacent, opposite, and hypotenuse. Hypotenuse, and we will say here is opposite and adjacent. So a quick review. If this is my angle, and I want to solve for this side, and let's say our hypotenuse is 27 meters. I'm first going to establish where is my unknown, which dimension, is it my adjacent, hypotenuse, or opposite? And so again, I've labeled this is now my opposite. So I know my formula has to have an O in it, it has to have an opposite. That can automatically take out cos for this triangle. Erase that. So now I've got to look at what other information do I have. I know it's either sine or tan because of the opposite. I'm also given my hypotenuse. Tan does not have hypotenuse, so I'm going to use sine. So I'm writing, step 1 is to write your formula first so that you can organize what variables you do have and you're taking the time to plug them into the right locations. So, and I forgot to give us an angle, let's say this was 33 degrees. So again, now I have my 2 pieces of information, 27 and 33. I didn't just come up with that from somewhere, that would have been given in a question. So we're going to go sine 33 equals, the opposite is our unknown, and the hypotenuse is 27. So I want to get rid of the 27 on the denominator, and I'm going to times both sides because this bar is our division. Times both sides by 27. So I have 27 sine 33 equals x, and the rest is calculator work. Again, it's important to know your calculator and know if you're pressing sine first, 33 first, the multiplication. Get comfortable with the calculator. Important to have the units. This question was in meters. It's a dimension, not an area, or a length, not an area. So we are going to leave it in the length of the opposite side of the triangle is 14.7 meters. If our triangle now wanted us to solve for the angle, and it gives us these dimensions, 14 length and 52 length. I'm first going to label what I know. So I know that this side is my hypotenuse, and the 14 is attached to my angle that's missing, so that's my adjacent. So which of my formulas have the adjacent and the hypotenuse? Well, cosine does. So cos theta We don't know what theta is, so that's going to remain our variable. And adjacent over hypotenuse. So cos theta, adjacent is 14, hypotenuse is 52. Now because we're solving for the angle, we have to use the inverse button on your calculator, so it's going to look something like that. Your choice, you can divide 14 by 52 first and get the decimal, or again you can do it all on your calculator by going cos, inverse cos 14 divided by 52, and you're going to get the answer of theta to equal, oh, it erased, 14 divided by 52, .74 degrees. 74.38 degrees, or round it to 74.4, or round it to 74 degrees. The important part to practice for most of us is over here. If x was on the bottom, it was on the denominator, you'd be timesing both sides by x, but then it would be over here, and you would still have to isolate it on this side, so dividing by the ratio that's there, the sine or the cos, whatever it may be.